winter is coming. And for you there in the Alps, that means avalanche safety is top of mind, right, Christoph? And you told me there is an MCP server for that?
Yes, people rely on LLM responses more and more when it comes to planning outdoor adventures. The data and information need to be accurate. Let me show you how I set up this MCP server.
Welcome to the show, Christoph. What do you do here at Google?
Thanks for having me, Martin. I'm currently doing a rotation as a software engineer in the Cloud Run team, working on the user experience. But I also work with the largest customers on Google Cloud to bring their serverless applications up and running.
Okay, now show me this Avalanche MCP server.
Someone might build the next generation Ski Buddy AI app, which can answer your questions about skiing and also inform you about the current avalanche risk. Such agent can connect to MCP servers to fetch this up-to-date data. For the purpose of this demo, I've connected my Gemini CLI to the URL of the Avalanche Warning MCP server, which runs on Google Cloud Run. But think of any app or agent. I'm going to ask here, what is the current avalanche danger level at Mountain Solstein? Tell me what the snowpack is like.
Okay, it's thinking.
Look at that. It asked me for permission to use those tools. Found the region ID for the Mountain Solstein, put the current data for this region, and got us a grounded answer based on the official records. No hallucinations.
All right, now why do we need an MCP server for Avalanche data?
It is actually a perfect use case. So the Model Context Protocol, or MCP, is basically a standardized way to plug in real-time data into a large language model. An LLM would not intrinsically know about most up-to-date data.
Okay, so it's like an open API spec, but optimized for AI?
Exactly. Standard APIs are messy for AI. You have to write good prompts and code to parse the model output to explicitly execute some API request. MCP, on the other hand, is self-describing.
How is it self-describing?
The MCP server tells the LLM, hey, I have a tool to check snow conditions, and explains how to use it in plain English. Here is a list of tools of the MCP Avalanche server, each written with a description and a JSON schema defining the tool's input.
Got it. But usually I see people running these MCP servers locally on their laptops. Why put this in the cloud?
Great question. Local is fine for personal offline tools, like reading from your own file system. But an Avalanche warning service wants to provide this endpoint directly, so users don't need to install the MCP somewhere, but just can connect to a public URL.
And why use Cloud Run for your MCP server in the cloud?
For Avalanche Warning Service MCP server projects, Cloud Run is a perfect match. Think about it, the traffic is spiky as a lot of people check the Avalanche report on a day when it snows, and they got prepared for the next day's outdoor adventure. But almost nobody is querying this endpoint at 3 a.m. in the summer.
And you don't want to pay for a server that's sitting idle all night, right?
Exactly. Cloud Run scales to 0. So if no one is asking about the avalanches, almost nothing is getting charged. But if a blizzard hits or champagne powder falls, traffic will spike suddenly. Cloud Run will scale up automatically.
I love that champagne powder. Okay, so that sounds efficient with the scaling. Now, how does the AI actually get the right Avalanche data?
Sure. Here is the Avalanche MCP server code by the Austrian Avalanche Warning Service. We expose two tools. One which is called getRegionID, you give it a mountain name and it gives you back this particular ID. And a second tool, you get the bulletin, where you can give it this particular ID plus a specific date and optionally a language. And it gives you back the danger rating and other related data in a structured way. Because they are clearly described in MCP, the large language model figures out the logic on its own, and it's chaining those two tools together.
Okay, I think I understand how that works. How would you deploy this MCP server to Cloud Run?
That is simple. We don't need to touch any server or clusters. I just run a single command to deploy this code as a Cloud Run service. That command takes my code, builds a container out of it, and provides me back with an URL and handles all the scaling rules we talked about.
Very good. Let's take a tea or coffee break while it's running.
I will pack my backpack to get ready for later, the good snow. And now it's back. Here is the URL of my newly deployed MCP server. I can give this URL to Gemini CLI or any AI agent. Someone out there built and want to rely on the Avalanche data.
Very good. Now let's recap. What are the main takeaways here, Christoph?
I have two. MCP is useful for connecting AI apps and agents to real-time data, like fetching Avalanche warning data. Second, Cloud Run is a great place to run your MCP servers because it handles all the MCP requests in a serverless way and auto-scales up and down automatically.
Great takeaways, and thank you for joining me today, Christoph.
Thanks, Martin, for having me.
And thank you, everyone, for watching. If you have any questions for Christoph or me, ask in the comments. And do let me know what you thought of today's episode. I read every single comment. I can't wait to see what you built.